mathematicians, and welcome to At Home with APS. My name is Mrs. Sears, and pretty shortly we'll be joined by Mrs. Gaudette, and we're working with you today on 3rd, 4th, and 5th grade math. Now, you guys know that we always do some kind of routine, some problem-solving task. We're going to have some books for you later on in this segment, and then we're going to finish off with a wonderful game. And all of these resources you can find on our At Home with APS website there online. And we just wanted to also let you know, if you would go ahead and get out your paper and your pencil, maybe you have a math journal or a spiral at home, and you can come along and do the routine with us and the problem-solving tasks. This way, you can kind of follow along in our thinking, but we want you to do the thinking and be able for you to, pick different numbers or pick different routines that you would like to keep going with at home. All right, so as you can see behind me, we have the number of the day. The number of the day today is 21,065. All right, what's different about the way I pronounce that? Didn't have any ands, okay? I don't see any decimal up there, so I don't need to put an and in there. But what's also kind of unique is, what do we have in that number? We have a 0 in that number. So when we have a 0 in a number, we don't necessarily say the place value for that particular number. So when I hear 21,000, that comma's telling me 1,000, I just say the last one as 65, right? 21,065. Perfect. All right, let's go ahead and put those into our place value chart. Are you ready? I'm ready. Let's go. All right, so first of all, we need to figure out, what are we going to put in our ones place? I'm going to start from the right to the left, okay? Let's see. How many ones do we have? We have 5 ones. All right. How many tens do we have? That T stands for tens. We have 6 tens. All right, when we're saying 6 tens, we say that as 60. Right now, the number that we're looking at is 65. No ands, right? We want to make sure we are not putting any decimals in there we don't need to. How many hundreds do we have? We have no hundreds. Not going to pronounce that one. It's still just 65, right? All right, how many thousands do we have? 1,000. All right, I conveniently put a comma in there for you, but make sure you have that comma, and when you read that comma says 1,000, right? So we know right now, before we have added in our 10,000s, we have 1,065. All right, how many 10,000s do we have? We have 2 10,000s. That actually is 20,000, right? So we have 21,065. How would you write that out in expanded form? I know we've talked a little bit about expanded form. Expanded form is when we're writing it out according to its place value. So if I have 21,065, how can I write that out in expanded form? All right, let's do that. Start with the bigger number first. We had 20,000 plus how many thousand? 1,000. Maybe I should put the comma there. Plus how many hundreds? Do I need to write this one? No, I don't need to put that 0 in there. Plus 60 in our tens, or 6 tens or 60, and 5, I don't know if I could have said and there, and 5 ones, right? Which gives us 21,065. All right, I'm going to give you a second to write that down, because in just a minute I'm going to switch the slide. So make sure you have this. This is our number of the day. We're working with 21,065. All right, let me get rid of that on there. And I'm going to go ahead. I think I can do it that way. All right, let's do that. How about that's a good idea. All right. Goodness gracious, maybe. There we go. Okay. So I'm going to go ahead and we're going to get started on our second part of the routine, which hopefully you guys already have up there. So we're doing more or less. All right. So we're using our number of the day. We're trying to figure out how much is 10 less, 10 more, how much is 100 less, 100 more, how much is 1,000 more or less, and how much is 10,000 less or more. You think you're up for the challenge? Okay, remember, get this in your journal or on your piece of paper because I want you to follow along with me, but you can try this first. You can pause it, do it first, and then see if you're right. Let's see. All right, so 21,065. How much or what digit would we need to be looking at if we're looking for 10 less? We're probably looking at this 6, right? This is our tens digit. Let's see if I got my pen in there. That's our tens digit, right? All right, let's see if we can do it. So we have 21,000. Am I changing my hundreds? No, I'm changing my tens. Instead of 60 or 6 tens, I'm going to have 5 tens, right? Perfect. All right, I went down one set of 10. So my number would be 21,055. What am I going to do for more? I probably got to go up a digit, right? So if we had 6 in that place, then what would we put next to make it 10 more? 7, right? All right, let's read it. 21,075. Did you get that? Good, good. What about the 100? Could we do a different number for our 100? Maybe let's do a different color on that one. How about we look at our hundreds? What's special about our hundreds? We have a 0 in there. This may take some thinking. I don't know. I was thinking about this, and how am I going to explain that? Because right now we don't have any hundreds in there, but what would be the number that usually comes right before we have that 100? Yeah, might be a 90, but in this case, we're kind of looking at 1,000 that's there. That's going to be a little bit different. We've got to think a little bit about that regrouping that Mrs. Gaudette was talking about yesterday. All right, so if we're talking 21,000, it actually for 10 less, 100 less would actually throw us back on our thousands place. We would have 20,965. I was telling them, I said it does make a difference because when you're looking at it, if you almost are kind of looking at this number without this 65, you have 210 hundreds right there. I'm taking away one of those hundreds. If I had 210 hundreds and I took away 100, I'd be left with that 209, right? So it's kind of hard to see, but we might be able to put it, if we want to, on one of our side things and kind of see where we regrouped. We basically regrouped one of those thousands to help us get back that 100. All right, so 100 more. So again, we're looking at that 0. What do we need to have there if we're doing 100 more? We probably need to add that 100 back to that 0, right? So we have 21,165. Ooh, getting really big on our numbers. All right, do we think we can do 1,000? What one am I going to be looking at? Which digit? I'm looking at the 1. All right, so I have 21,065. What is 1,000 less than that? 1,000 less? Well, we're going to take away that 1,000. So we have that 65. Ooh, I almost messed up there. That happens sometimes. I was thinking about that and I really don't have to change these other digits that are here. I get to just leave those the same. The only digit that I'm working with is in my thousands place. So I instead don't have a 1,000, but I took away that 1,000. Now I only have 20,065. Okay, you think you can do 1,000 more? Of course you can. Let's see that. All right, again, looking at that one in that thousands place, what are we gonna do? We're gonna add another 1,000. So we have 22,065. All right, now the big one, huh? Ooh, I'm excited about this one. Let's see, maybe I can just keep doing my little color scheme here. It seems to be working. We're looking at that digit in the 10,000s place, right? We need to do something to it. We need to take away 10,000 of that. I have 20,000, I have 2 of them in there. Now I'm gonna be doing which one? I'm taking it and I'm making it smaller. All right, so I have 10,000. Ooh, did you see what I did? So I totally messed it up and put it all the way about. Do the undo? Nope, it won't let me anymore. Oh well, we will fix this one, and actually we'll finish this off. We can probably finish this off here in our next segment. But actually it is time for Ms. Gaudette to finish and come on up here for our problem-solving task today, which is gonna involve our fractions. All right, Ms. Gaudette, I'll have you come on up. I'll probably forward that on for you.
All right, everyone. So we are going to be working with fractions. And last time we were together, actually, I should say this, it was a week or 2 ago, we had talked about Andre and his friends coming over to his birthday party and talking about sharing a cake. Last time we had talked about sharing, it was in eighths, and we had 8 pieces, and they asked, was it shared equally? And it was not, because the pieces were all different sizes. So here's where we're at. Now 2 more of Andre's friends come. So how many friends do we have now? 10. Thank you. Joe, don't forget, I'm gonna be asking questions, and I want you guys to call out the answers to me, okay? And also, if you don't have a writing utensil and your math journal or paper, bring it on out. You can also download this off of our website, APS at Home, and you can go ahead and do the work right on there. All right, so 2 of his friends came. They decided they will all share the second cake. Show how Andre can slice the second cake so that he and his 9 friends can each get an equal amount with none left over. What fraction of the second cake will they each receive? All right, so I always circle, right, to help us out. So we have here, and I'm gonna move this down to help us out. I have 2, right? I heard that, thank you. Was there any other numbers that we needed? He and his 9 friends. That's a good number for us to have. All right, do we have any other numbers? I don't see any. All right, what are we being asked to do? 2 of Andre's friends come late to his party. Are we being asked to do anything there? Nope. They decide they will all share the second cake. Are we asked to do anything there? Not yet. It's still just information given to us. Show how Andre can slice the second cake so that he and his 9 friends can each get an equal amount with none left over. Are we being asked to do something there? Yeah. We have to show how you can slice the cake, so that he and his 9 friends can get an equal amount with none left over. All right, we know that much. The last one says, what fraction of a second cake will they each receive? So what do we, thank you, what fraction? And it's not just any fraction, it's each receive. All right, so what is our first step to solve this? Right, we gotta split up that cake, but how many pieces do we have to do? The 10 pieces, right? So how could we take our cake and split it, and we have a nice rectangular cake? How can we split it up? That would make it easy on us. Can we do like, I was just thinking back to that one where we took book where we had the cake and we split it in half for the elephant, then the hippo or rhino split it in half, and then they kept splitting it in half. Would that help us for 10 people? No, we'll never hit 10. It will always be have leftovers or not enough. So what could we do? Right? We could do fifths. So if we took our cake and split it into fifths, so I'm going to go ahead, and fifths are kind of hard because when I'm doing them, I always try to think I have 5 pieces, but how many cuts will I have to make? And it's always one less 4 is how many cuts I'll make to make that 5 pieces. So I'm going to try to get 4 cuts in here. 1, 2, 3, 4. All right, let's make sure if I did this right. 1, 2, 3, 4, 5. I got my 5 pieces, but I need 10. How can I take my 5 pieces to make my 10? Right? Split it in half. I'm thinking of a cake. I could have done it long ways, and each person had this long, skinny piece, but I'm just thinking of a cake, so I'm going to cut it horizontally just to make it easier on me. So we have 10 equal pieces. You notice I said about, it's about equal. Pretend they are equal. So I have 10 equal pieces. And then it says, so I've done show how you can slice the cake. We've sliced the cake. I've done that. So it's equal amounts with none left over. Have I done that? Mm-hmm. And then it asks me, what fraction of the second cake will they each receive? Have I done that? No. So I'm going to just color in one of the pieces because that's just me. I like to see how much each person will get. They each get 1 slice, which is how much out of the whole cake. It's 1 slice out of 10 pieces, which is the whole cake. So each person will receive, and I'm going to spell this wrong, RECEI. Thank you. You don't hear it, but Miss Sears is in the background helping me spell because one of the things is I'm dyslexic and I mix up my numbers and my letters all the time. And that's one thing that I always have to work on and be cognizant of. So each person will receive 1/10 of the cake. All right, did we answer every question we were asked? Yep, we were. So we're going to go ahead and move on to the next question. All right, we're sticking with Andre. We like Andre. Andre thinks it's strange that 10 of the cake would be less than 8 of the cake. I think he's talking about those pieces, since 10 is bigger than 8. To explain to Andre, draw 2 identical rectangles to represent the cakes. Show 1/10 shaded on one and 1/8 shaded on the other. Label the unit fractions to explain to him which slice is bigger. All right, so very fast. Are we given any information in the first sentence? We have they're numbers, 8, 10, and 8. All right, 10 is bigger than 8. Is that and do we have to underline anything? No. To explain to Andre, draw 2 identical rectangles to represent the cakes. Do I need to circle the 2? Is that any information to help us solve it? It is, but it's what we're being asked to do. It's not a number that we have to work with after that. So I'm just going to underline. Draw 2 identical rectangles to represent the cakes. Show 1/10 shaded. That's a number we have to circle, right? We have to circle this because we know that 1/10 is shaded, and I'm going to underline that, on 1, and 1/8 is shaded on the other. And then what do we have to do? Label the unit fractions and explain to him which slice is bigger. All right, so we know what we're doing. Do you? Right? What do we have to do? Draw two rectangles. So I'm going to draw long, skinny rectangles because it just makes it easier for me. And I draw them right on top of each other because when I'm comparing, it makes my comparison easier. I'm going to start with the eighths because the eighths are easier, and I'm going to use that example of the cake from the book where we had to keep cutting in half, 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 half. So we know to get eighths, we can start with a half, and then from a half, we split each piece in half again to get fourths, and then, right, split it in half again to get eighths. All right, now for tenths, what number do we have to start with to make it easier on us? The fifths. We did that last time, right? So we know we're going to draw 4 lines. So let's go ahead. I know I'll have to have about here. I probably shouldn't do that, right? I know that's not going to be. I have one there, one there. Am I getting off on this one? You're all, Mrs. Gaudette, those look awful. Yeah. I'm sorry. It's about, remember, when we're freehanding it, I don't have a ruler with me. And then I take those, wait, is that fifths? 1, 2, 3, 4, 5. Yes, that is fifths. So then we take it and split it in half to make tenths. All right. And we were told then to draw the 2 identical rectangles showing a tenths and eighths, which we've done, and then label the unit fractions and explain to him which slice is bigger. All right, so we got to label the unit fractions. So we know this is eighths, which is 1/8, or we could do the whole way across that each unit fraction is eighths, all the way across. What would we do on the bottom? Tenths. So we can put 1/10s, 1/10, because we only have one piece all the way down. So looking at our example, which isn't the best, which one do you think is bigger, eighths or tenths? It's the eighths, right? We can see that because I only have to share it with 8 people, I get a bigger slice. But every time I have to share it with more people, I get a smaller and smaller and smaller slice, just like that book with the lions at the lion's birthday where they kept cutting it in half. So we have to explain to him which slice is bigger. So we can explain that 1/8 is bigger. Why? Why is it bigger? You guys remember our discussion? Because if you split the cake into more pieces, thank you. Is it IE or EI? It's correct? Okay. They're saying to me, and I was like, they say I after E except for C. And I'm like, is it correct or not? Yeah. So the cake into pieces, all right, 1/8 is bigger because if you split the cake into more pieces, you get a smaller piece. It does, everyone, because what happens with decimals and fractions, the bigger the number is on the fractions on the bottom, the smaller the piece. It's opposite of what we would think. We're so used to whole numbers where the bigger the number gets, the more you get. But in fractions and decimals, when you get the bigger number in the denominator, it gets smaller and smaller and smaller until you get almost nothing. All right, let's move on to our next task. We're moving away from Andre. So a ribbon is 1 meter long. We're told it's 1 meter. Perfect. Mrs. Lee wants to sew a bead every 1/5 meter. The first bead is at 1/5 meter. The last bead is at 1 meter. Draw and label a number line from 0 meters to 1 meter to show where Miss Lee will sew the beads. So, label all the fractions, including 0/5 and 5/5. Label 0 meters and 1 meter too. So I'm going to leave this with you to go ahead and try that out. If we were starting here, we can label 0 meters and we can label 1 meter. Where would you put those fists? Yeah, today we've worked a lot on fists. So this, try it out. See where those beads would go. All right, guys, we're going to be moving into the Sunday split, or what was it?
The Sunday scoop.
The Sunday scoop. So we get to talk some more about ice cream.
Yeah. Let's see. Will that go away if I just hit that? I think it will. All right. I just want to get rid of that one little section there. Doesn't seem like it wants to go. We may have to have it there. Okay, so if you recall, yesterday we were reading a book. It was called The Sunday Scoop. Now, Sunday, not like in the name of the day of the week. Sunday as in ice cream, right? Like Sunday Scoop. And if you recall, there was Miss Winnie. She was the head of the cafeteria. They also had James, Lauren, and Emily, and Miss Winnie's cat Marshmallow. And in there, they were having a picnic, and they were going to have a booth. And they thought about having a Sunday booth at their picnic. Well, they had to make some decisions before they can decide what they wanted to have represented at their booth. So in order to do that, they came up with, we're going to have 2 flavors of ice cream. We're also going to have 2 different kinds of sauces, and we're going to have 2 different kinds of toppings. And I believe it was Emily, but Emily kind of was like, wow, is that going to be enough? And that's kind of where we ended. We tried to figure out how many different combinations could the children make, right? All right, let's see. Let me get this on here. And we had said for all of the different kinds of ice creams, remember they chose chocolate and vanilla. Make it simple. Yeah, I'm with you on that. Hot fudge caramel for their sauces, and sprinkles and nuts were going to be for their toppings, okay? And when we were thinking about how many did they make, well, in all, we had chocolate, hot fudge, and sprinkles, 1. We had chocolate, hot fudge, and nuts, 2. We had chocolate caramel sprinkles, 3. We had chocolate caramel nuts, 4. We had vanilla, that's just the chocolates, right? Vanilla, hot fudge, and sprinkles. Oh, I'm getting hungry just thinking about it. Vanilla, hot fudge, and nuts. And then vanilla, caramel, and sprinkles. Now we're up to 7, right? And our last one, we had vanilla, caramel, and nuts. So how many was that all together? So given each Sunday has to have 1 flavor. I know Miss Gaudette asked that. She wanted to have 2 toppings on hers. Each one has to have 1 flavor, 1 sauce, and 1 topping to be the Sunday, right? That's what they're going to be giving out. So 2 flavors times 2 sauces times 2 toppings is going to give us 8 different combinations. You can see them all there, right? All right. So let's see if I can do that like there. There it goes. All right, we're going to get back into our story and see what happened on this Sunday scoop. I think it's kind of interesting. All right. So we were there at the chart. And by the way, this is the Sunday scoop. It's written by Stuart J. Murphy, illustrated by Cynthia Jabbar, and HarperCollins is the publisher, okay? You can see Miss Winnie, she kind of drew that same chart that I had up there with all the different flavors and all the different combinations that were behind us. All right, the day of the picnic was sunny and warm. Everyone wanted sundaes. Let's get scooping, said Winnie. Look at the line, Lauren whispered to Emily. Emily looked up. I hope we still have enough of all our favorites left for ourselves, she said. Wow, they've got like a good little assembly line going there with all their different flavors of ice cream and then sauces and toppings. Looks yummy. Emily scooped. James poured the sauce. Winnie added the nuts. And Lauren did a little dance as she shook the sprinkles. And a 1, and a 2, and a 1, 2. Whoops! What did she do? She spilled all of the sprinkles. Oh no! What are we gonna do? That was all the sprinkles we had, complained Emily. Yeah, said James. There goes my favorite. What's Marshmallow doing? Marshmallow's licking them all up. She must like those sprinkles. Let's change the sign, said Winnie. Now we're down to 4 different kinds of sundaes. Let's see, does that work out? What happens if I have to get rid of those sprinkles? I got no more sprinkles. None at all. Does that change my combinations? I'm just gonna point to them as we go. So let's see. We have chocolate hot fudge nuts, chocolate caramel nuts. We have vanilla hot fudge nuts and vanilla caramel and nuts. 4. All done with that one, huh? So if we're thinking about like our our toppings and how we wrote out our sentence before, we have still 2 flavors times our 2 sauces. That's 4, but we only have 1 topping. We're stuck with 4. All right, let's see what happens next. No more sprinkles. All right, James started to pour the caramel sauce for the next sundae. Watch out for marshmallows, said Lauren. Where? Said James. James, said Emily, look where you're pouring. Oops, said James. Oh my goodness, he's poured out all the caramel sauce. I guess that we're gonna have to change that sign, huh? That's it for the caramel sauce, said Lauren. My favorite, sadly. Now there's only 2 sundaes to choose from, said James. Better change the sign. Let's get up there. All right, what did we got? What did we lose? Lost that poor caramel now. All right, so done and done. How many do we have now? Let's think about this because we still have our 2 flavors of ice cream. And how many sauces? We only have 1 sauce, right? Now, how many toppings do we have? 1 topping, right? How many are we gonna have? Sundaes combinations. We're gonna have our chocolate hot fudge and nuts and our vanilla hot fudge and nuts. 2. All right, let's see how this ends. Doesn't sound very good. I don't know if they're gonna have any ice cream left after all of this. Keep messing up all their things. The sun got hotter and hotter. Scoop faster, Winnie told Emily. The chocolate ice cream is turning into chocolate soup. Have you ever had that happen? Not very good. Emily scooped as fast as she could, but it wasn't fast enough. There goes my favorite. It looks like it's Marshmallow's favorite too. Marshmallow's really getting a lot of ice cream and sprinkles and all kinds of fun stuff in this. I can see he really likes it or she really likes it. Better change the sign. So now what did we lose? We lost a flavor of ice cream. Let's see what that's going to do to the sign. All right, you ready to see? What are we getting rid of? What do we not have any more of? Because now Marshmallow's eaten it all. We have no more chocolate, right? It's chocolate soup. All right, so what do we have left? It's not going to really help us to have our hot fudge or our nuts in this case because there's no ice cream to put it on. And remember, every sundae has to have what? has to have at least in a flavor, has to have a sauce, and it has to have a topping. So what do we have left? We have vanilla, so we have that one. How many toppings? One sauce, and we have one topping. What is left in the line? One different combination. Oh, vanilla. We have, I think it was the caramel sauce that I got rid of. Maybe it was the other one. Okay, let's see. Vanilla, ice cream, and hot fudge and nuts, said Winnie. My favorite, pass the spoon. So did they get their favorite? Yeah, the line was long enough, but they were still able to get their favorite. Let's see, did they get what they wanted to get? They did. All right. I really like this book because it has all of the different combinations that you can kind of put together in the front of the book. And before we go ahead and we go on to our next one, I want to make sure that you guys understood what we were doing. What was happening in the story as we were getting rid of the different flavors and toppings and sauces? We were changing our multiplication sentence, right? All right, so each time, and this is what we call a tree diagram. So a tree diagram, we just kind of mapped out what were our flavors, what were our toppings, and what were our sauces and what were our toppings. And then we kind of manipulated them as we went through and figured out how to get those different things. All right, I'm gonna do another story for you. I'm gonna go ahead and just get rid of that one. This one is called Infinity and Me. All right, it's not about combinations. It's more about thinking about this particular number, infinity being the number. So when we're talking about things that we can count, you can usually count things that you can find around your house, right? You might have like cans of soup. You might have like different things like rocks you might be able to find. Can you count specific blades of grass you might have in your yard? You could, but it might take a long time. Can you count the stars in the sky? You could, but it might be something that you cannot count. One of the things that we think about when we cannot count, can you measure like somebody's love for you? If you have a mom or dad or grandma or grandpa, somebody that's significant in your life, can you measure or count how much they love you? Well, this story, we're going to talk a little bit about a little girl. And she has a grandma in this story, and we're going to kind of talk about some of the things that she thinks about. She's thinking about this idea, this concept of infinity. All right, we'll see how far we get. And if we don't finish it, then we'll get into it tomorrow. And this book is by Kate Hosford, and I'm going to totally obliterate this name, illustrated by Gabby Swakatska. Gabby Swakatska. That sounds like a very interesting name. And it's published by Carol Hoda Books in Minneapolis. And it's called Infinity and Me. All right. That night, I got my new red shoes. I couldn't wait to wear them to school. I was too excited to sleep, so I went outside and sat on the lawn. When I looked up, I shivered. The sky was so huge and cold. How many stars were there in the sky? 1 million? 1 billion? Maybe the number was as big as infinity. I started to feel very, very small. How could I even think about something as big as infinity? You ever thought about infinity? Seems pretty big. At school the next day, I asked my friend Charlie what he imagines infinity is. That's easy, he said. It's a giant number that keeps growing bigger and bigger and bigger forever. I thought about trying to write the number down, but even if I lived forever, I would never finish it. Look at all those numbers. They're writing them forever and ever. They're not going to live long enough to write them, right? They could still keep going. I went to get ice cream after school with my best friend Samantha. Sam, I asked her, when you think about infinity, what do you see? I see the infinity symbol, she said. It looks kind of like an 8 that fell over and took a nap, doesn't it? Looks like an 8 that it's just lying down, took a nap. And I think of it as if it were a racetrack, I could drive around it forever. Samantha made me feel a little bit better. Writing that symbol would not take as long at all. I traced the napping 8 in the dirt with my shoe. Doesn't that look kind of fun to do? Before school the next day, I asked Grandma how she imagines infinity. She smiled at me and said, I like to think about a family. First, you have the great-grandparents, then the grandparents, parents, children, grandchildren, and great-grandchildren. It could go on forever. Have you ever thought about infinity that way, as in all the people in your family? It could go back generations and generations. Let's see. I couldn't really imagine that many people in one family, but I did realize something. It was hard to talk about infinity without talking about forever. I also realized something else. No one had noticed my new red shoes. Not even Grandma, who usually notices everything. I looked down to make sure that they were still shiny. Then I started to wonder, what would I like to do forever? Can you think of things you'd like to do forever? Maybe you're thinking, I'd like to have recess forever, right? At first, I thought I might like to have recess forever. But if there's no school before recess and no school after recess, is it really even recess anymore? Yeah, not having any boundary doesn't really make it like you're going to do recess forever. That's going to be kind of hard to do. All right, maybe I would lick an ice cream cone forever. But what if my tongue started to hurt? Actually, my head was starting to hurt from all of these thoughts. Could you be doing that all that time? Oh, that'd make my brain hurt too a little bit. When I went to the lunchroom, I asked our cook, Mr. Mancini, how he imagines infinity. He held up a noodle. How many times do you think you could cut this in half, he asked. Kind of like what Miss Gaudette was saying. We're cutting it in half and in half and in half. I cut it in half 6 times, but it got too small, and I was afraid I might cut my finger instead of the noodle. In your mind, Mr. Mancini, could you cut that tiny of a piece of a noodle in half forever? It's pretty tiny, right? The bigger that amount of pieces, the smaller the piece that you're going to end up getting. Pretty soon, you might not have anything to cut. I asked Mr. Reed, our music teacher, Miss Reed, our music teacher about infinity, and I wish I hadn't. Picture music that goes on in a circle, she said. The notes would lead us around and around. The music would be endless. So we're talking endless. There's no limits as far as our recess. It can cut it in half and get smaller and smaller. I was starting to think that my questions about infinity might be endless. It was time for me and my red shoes to go home. She seems a little depressed. She doesn't know what's going on with that big number, huh? For dinner, Grandma made my favorite meal, butter chicken and rice. As she mixed the pieces, she looked at me and said, Uma, I meant to tell you this this morning. Those are the most beautiful shoes that I have ever seen. I didn't hear the rest of what Grandma said. I was too busy smiling. Right then, I knew my love for her was as big as infinity. And that's how love is. It could be bigger than you ever think. That night, I asked if she would look at the stars with me. Snuggled up next to Grandma, the sky didn't seem so huge and cold anymore. Now it was more like a sparkly blanket covering us both. The end. All right. I'm going to go ahead and stop right there, but I did have an activity for you to do, and maybe you can do this at home. So we were talking about infinity being big, huge, but endless, and you could do the cutting the noodle that Mr. Mancini was talking about, where you can cut it in half, and then cut it in half again, and then half again. See how far you can get cutting it and how many pieces you could get and how long it would take you to get to infinity. Quite a long time, right? All right, Ms. Gaudette, we need to get over there and I'll get you there.
Our last activity is our game. We're going to be playing a multiplication memory game. So really fast, Mrs. Sears is awesome. I have some memory cards. You can go onto our At Home with APS website and go ahead and download these so that you have the multiplication cards as well. And the goal, just as in memory, you lay them out, you shuffle. Okay, hold on. You shuffle them first. You shuffle them, so let's shuffle them.
She might have put something in there that she knew was right on top.
Maybe. Mrs. Sears, I might do that just for you. All right, I'll cut the deck so I don't know what's on top.
And our cards, by the way, have different representations that you could do with multiplication. So that might help you kind of with memorizing your facts or getting your facts kind of down. You'll see different ways that it might be represented. It might be represented with a symbol, like our times symbol. It might be represented in an array. It might be in repeated addition. So there's all different ways you will be able to see it. And kind of just like you're thinking in memory, you're going to want to like pull over one of the cards and see if you can find a match, right? What happens when I think you get the match? Do you get to keep it?
Get to keep it.
All right. Do you want to do rock, paper, scissors and see who goes first, or do you just want to start us off?
I'll just start us off. No, I got to do the rock, paper, scissors. I got to do that. All right, ready?
Rochambeau.
1, 2, 3. Oh, you watched me. You cheated.
Okay, I'll do it behind my hand. No, let's do it. 1, 2, 3. All right. See, that time I did it. I did watch the first time. Sorry. Okay, let's see. I'm going to pick this one. Can you see that okay? If I did it this way? Is that a little bit better? So I got 7 times 6. So I'm looking for something that's 7 times 6. So I'm hopefully
equivalent
to 7.
Wait, what is 7 times 6?
42.
All right.
All right. Because I know 6 times 6 is 36. I just add another group or a 6. All right. I got 4 times 8. Wah, wah. That's 32. I got a 2 at the end.
Yeah.
Does that count for something?
Nope. Has to be equivalent amount.
All right. Let me leave that there. Now I want to remember what I pulled over because why? Because next time when I go to it, what if I did find 42 or I found 32 instead? I probably want to make sure I remember where I pulled it from.
So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of 4, which is 36. And then
Trying to pay attention.
6 times 7, which is 42. Oh no. Hopefully she won't remember where that was.
I think I do. What am I going to do? That's just that commutative property, right? It just switched the factors around. Oh, yes! It's near there. It's near there.
You see why I was clapping is I was like, she purposely made it so it was all cockeyed.
And then I couldn't remember where it was.
So 7 times 6.
Maybe I moved it.
6 times 7 is 42. So I get those.
Oh, no.
And then let's
See, I did that on purpose.
So I have 1, 2, 3, 4, 5, 6, 7 groups of 6. Oh, that would have worked. Another way to represent it.
Yes.
Well, I have one more. Let's do the corners. Might as well. 8 times 4. Nope.
Let's see. I'm trying to remember where your other one was because I think she did have a 36. Wasn't it like 9 times 4? Let's see if I got it right. Oh, well, okay, that worked. 4 times 9. It wasn't the same representation that I was thinking, but I did get, let's see if I got that. 36. 4 times 9 is 36, right? Because if I had 10 groups of 4, I would have 40. So really, to take away one group of 4 would be 36, right? All right, do I go again or do?
In memory, you keep going.
Oh, let's see.
At least how I played memory.
Let's see. I think I had 4 times 8 right here, but I remember you getting the 32 earlier. I'm going to get, well, they were right near each other. So 8 times 4 and 4 times 8, that's that commutative property. We're just switching around the factors in there. They're going to both be 48, 32.
You shouldn't get them.
I shouldn't get them, but they are 32. I was thinking 32, and I don't know why I said 8 times 8. I think I copied the numbers in there. I'm going to say that no, I can't get them because I said the wrong thing.
Really?
Yes.
You're going to give me a giveaway?
Well, if you want.
Well, I'll take it then.
All right.
8 times 4
I would
and
think,
4 times 8
I would
is
think
32.
that I would have to say the correct number. I just put the numbers together in my head. And, we make mistakes, but we have to be honest and use that time.
7 times 9 is not 42. 63.
Okay. And I've got to remember, because she did have a different way of representing it, and I just can't remember where that was either. I got to really memorize my things. I think I'm too far away, and I need my glasses with me. Oh, now I've got something completely different. So let's see. This looks like we have 4 groups of 8 each. Okay, so that would be 4 groups of 8 each would be 32. Where did we see that last 32, or did I get it? You took it. Wow. All right, let's just try a shot in the dark. Who knows? Maybe I'll get lucky. Oh, this one has an array, and it looks like it's
Here, you want me to read it?
Yeah, it's got a 4
times 8.
4, we've got rows, 8 in each row. I think I did it. I think those would both work. 4 times 8 is 32, right?
It is.
All right, because it's got 4 rows, 8 each, and then here's my 4 groups of 8 each. I think that works. That's 32. Just a different representation.
Yep. All right, it's your turn again.
All right, let's see. Let's see if I can catch her. We both have 2 each. Maybe I'll get the before we get done here. I have 4 times 9. Can you say that?
4 times 9.
Okay, 4 with 9 in each row. That's how many? 36. I'm not going to make this mistake. Did she take the 36? 7 times 9 is what I found. Okay, so a little bit more than I needed on that one.
All right.
All right.
So let me try.
I think we have enough time for maybe one more unless you get on a roll.
I have 9 groups of 7. 9 groups of 7 is 63. Yay! I got a match.
You did.
She's like, I can see it in her face. All right, I have 42. And I don't remember what these were. Oh, and 32.
That might have helped for something.
It might have helped Miss Sears and
Let
not
me see,
me.
though. Hopefully I get one more. I might have been off on this one. Oh, maybe I'm not there again. So we have dominoes this time. We have 4 and 5. That's 9. But I have 4 groups of 9. That's 36. I keep getting this 36.
You do?
But all these different ways that I'm doing this 36. Let me try it. I don't think, that's the 32. Did you already have a 32? I don't think I'm going to be lucky this time, but I only know we probably don't have any more time left.
Oh, darn. You could tell I was really hoping. All right.
Try it. You might be able to get that.
All right, so today we did a number of the day, 21,065. Ooh, we're getting better of not saying and. Then we moved into a task with Andre and cutting his birthday cake. I can't even talk anymore. Then we read 2 books. We got to do this Sunday Scoop and finish that up, and then read about Infinity and Me. That's actually really nice. Contemplate that. Think about it. See what you can do. And then we did a great activity with multiplication memory, and there are a lot more cards. I have here a lot more that I just took out so we only had 24. But you can do as many cards as you want. But remember, you have to have the correct answer, right?
Yes.
So just play it like memory, but make sure you're thinking about how are those facts related, either arrays, different representations, the multiplication. So I want to thank everyone for joining us today for At Home with APS. Have a great day.
Thank you, guys.
Bye.
Bye.